Hi student, welcome to the new topic, that is project on AutoCAD for electrical power distribution layout for commercial kitchen. There is the intermediate level. To do this project, you must have the following skill set. You require AutoCAD 2D, knowledge of kitchen equipment, power requirement in watts for kitchen equipments. Participant will be able to implement power distribution for kitchen area, basic requirement of electrical supply for kitchen, and power supply for kitchen services, that is equipment and lighting and fire safety equipments, etc. By this project, you will learn the alternate current and direct current, that is AC and DC power supply for kitchen equipment, point wiring for each kitchen equipment, switch and socket location in a kitchen area. There are the prerequisites for this project. You must have the knowledge of power consumption in watts for each kitchen equipment. Then AutoCAD 2D and single line diagram, that is SLD, and symbolic representation of switch and sockets. The target students for this project are electrical engineers, electrical draftsmen, engineers working for kitchen consultants, and students who want to make career in kitchen services design. By the end of this project, you will have the following skill sets: commercial kitchen electrical design, power distribution layout for commercial kitchen, switch and socket location for kitchen area, and point wiring. The case study says, a 5-star hotel has decided to build a well-equipped commercial kitchen for their all-day dining area, banquet hall, and guest room service. Their aim is to cater food as per the customer requirement. So, as part of this case study, we need to provide the proper power supply to all kitchen equipments in order to work 24/7 hours. Let's use AutoCAD to do the same. Following scenario will be covered as a part of this case study. First, location of the kitchen equipment. Second, power requirement for kitchen services. Third, power distribution from main DB, that is distribution board. Fourth, switch and socket location. Fifth, power wiring from socket or switches to kitchen equipment. So let's start. Hello students, welcome to the new topic, that is project on electrical power supply layout for the commercial kitchen. In this layout, we will give the power supply, switch and socket as well as the distribution board for each and every kitchen equipment. So let us start step by step. So here we need to give the steps for electrical layout, electrical power supply layout for commercial kitchen. We need to consider each and every steps. The first step is introduction of kitchen equipment with wattage and tag number. This is the first step. It means we need to introduce the kitchen equipment, the name of the kitchen equipment with its wattage as well as with the tag number. So it will be very easy to understand the power requirement for that particular kitchen equipment. The next step is location of switches. And sockets for each electric kitchen equipment. The third step is wiring connection from main DB to switch and socket and socket to electric kitchen equipment. Next is the fourth step. In this step, we require power distribution schematic diagram. In this diagram, we need to give the connection of the power equipment, that is the electrical kitchen equipment, to switch and socket, and from switch and socket to main DB, that is distribution board. Next step is power supply legend. The power supply legend contains the legend of the power equipment, that is the power point, required for each and every electrical kitchen equipment. So power supply point legend is there. Sixth step is list of kitchen electric equipment. List of kitchen equipment is also important. And the last one is viewport setting with title block. So these are the 7th number of steps for electrical power supply layout for commercial kitchen. So we need to go step by step by this drawing. Let us start with first step. The first step is introduction of kitchen equipment with wattage and tag numbers. Here is our commercial kitchen drawing. In this kitchen drawing, we can see there is the multiple kitchen equipments available into this drawing. So let us start with this room called as a dishwash room. So in the dishwash room, we can see some electrical equipment like dishwasher, this kind of a dishwasher, the vertical type of dishwasher, the horizontal type of dishwasher is also there. So here are two electrical kitchen equipment is available into the dishwash area. So we need to give the power supply for this dishwash area. So for that, I need to give the wattage for this dishwasher. Normal dishwasher of the vertical type dishwasher requires 3000 watts. I have mentioned over here the 3000 watts. Again, this horizontal type dishwasher also required a minimum 3500 watts. So these are the two dishwasher available into the dishwash area. And I have given the wattage for this two types of dishwasher, as well as we need to give the tag number for this electrical equipment. So I will give T1, or you can put K1 also. That is the kitchen legend. So K1, I will give the serially K1, K2, K3 like that. So here it is, I have given K1 tag number. Here I will give K2. We can make the layer for the tag number like this. So here it is tag number, and color you can randomly choose like this. This is the tag number color. So I will give the layer for the tag number like this. So this is K1, K2. And this K1, K2 I'll mention over here, that is the tag number K1 vertical dishwasher, the quantity 01, the power requirement 3000 watts, and the phase is single phase. That is single phase I have given over here. Tag number K2 horizontal dishwasher, quantity 1, power requirement is 3500 watts, the phase 3 phase power requirement for it, because it crosses the 3000 watts. So if it is 3000 watts, we can give the 3 phase because it has higher capacity motor. So I have completed this dishwash area. So as I have completed this dishwash area and mentioned into this chart tag number, kitchen equipment name, quantity, power requirement and the phase. So next area is room service. In this room service there are the multiple kitchen equipments are available. Induction stove is there, juicer mixer is also there, coffee maker and tea maker machines are available. These are the electrical equipments into the room service area. So I have to mention over here, firstly I need to give the tag number for each equipment. Here it is K3, K4, for coffee maker K5, and for tea maker K6. So induction stove requires minimum 3000 watts. So I have given over here K3, induction stove in room service area. So I can mention over here because the multiple induction stove is available into the commercial kitchen. So we need to specify the room service induction stove. The quantity is 1, 3000 watts, and it's a single phase. Next is a K4. It's a juicer or mixer. It requires maximum 1000 watts and it is a single phase. The next K5 is coffee maker, quantity 1, 1000 watts, single phase, and K6 is the tea maker or the tea vending machine. I'll mention over here a tea vending machine. It is required 1000 or hardly 800 watts in a single phase. So this is I have done with service room also, or the room service area. Next is the cold kitchen area. In the cold kitchen there is one induction stove, a refrigerator and another refrigerator is there. So 2 refrigerator is available into the cold kitchen area and 1 induction stove is available into this. So for this entire cold kitchen, I need to give a tag number. The tag number is K7. We need to exclude the refrigerators and the other cold areas like chef refrigerator, then chef freezer. These are the excluded kitchen equipment which requires a special arrangement of switch and socket. So I need to exclude that. Next is kitchen exhaust fan. Kitchen exhaust fan is the special ventilation fan required to exhaust the fume or the required kitchen exhaust. So in this area there is the huge smoke created due to the cooking and frying. So we need to give the exhaust. We need to exhaust all this air and throw it to outside by this kitchen exhaust fan. So kitchen exhaust fan is the very most important ventilation fan required in a commercial kitchen area. This kitchen exhaust fan requires the electrical power. So as per the entire kitchen area and the requirement, the vendors gives us the exact power required for the kitchen exhaust fan. Here it is, I have taken for example the 11 kilowatt, or it is 11,000 watts. Same over here, I will give for the fresh air fan 10 kilowatt or 10,000 watts. So I have done this and I need to give the tag number for this K7, K8 and here is the K9. So K7 is the induction stove of around 1000 watts single phase. K8 is the kitchen exhaust fan and that is 11,000 watts with 3 phase, because the motor available into this kitchen exhaust fan is a 3 phase motor. Next is K9, that is kitchen pressure fan with 1000 watts 3 phase. So I have covered up all this area. Now come to this main kitchen, that is the entire hotel kitchen. This is the main kitchen. Into this main kitchen, the multiple equipments are available like griller, toaster, microwave oven, idli maker, dosa maker, then gas hob, OTG, electrical tandoor. Different types of electrical power equipment are available into this main kitchen. So I need to give each and every kitchen equipment a tag number. Tag number is a very important to give for each and every equipment. So here it is, microwave oven. I have given K9, so I will give here a K10. The next is for the idli maker, it is K11. For dosa, electric hot plate for dosa, it is K12. Griller and toaster, K13. Here are two numbers, griller or toaster. So I will start with this K10. The K10 is microwave oven with 3000 watts and it is a single phase, whereas K11, it's an electric idli maker that is around 2500 watts with a single phase. K12 is dosa maker, so it is electric hot plate for dosa that is around 3500 watts. So it will come three phase, or it can be available into single phase also. Extend this line over here. The next is K13. K13 is a griller or toaster, two numbers. Quantity is 2 number and it is around 1500 watts. It is 1.5 kilowatts for the single phase. So K13 griller or toaster, two numbers, 15,000 watts, single phase. After that, we need to give the next tag number, that is K14. For this OTG, it's an electrical equipment. So K14 OTG is there, quantity 1 number and power supply is 1000 watts single phase. The next is electric tandoor. I have to give the next tag number, that is K15 for the electric tandoor. Here is the coal tandoor. Coal tandoor is not working on the electrical power supply, but the electrical tandoor requires the electrical power to run. That's why electrical tandoor comes into power load. So I have given the tag number, that is K15. Here I will mention electrical tandoor. Electrical tandoor required 4800 watts and that is three phase. The next one is electrical hob, that is K16. We need to extend this K16 electrical hob or cooking range, that is 3 numbers. Each hob required 1500 watts and it is in a single phase. Here it is, electric tandoor. Previously I have given one electrical tandoor, that is 4800 three phase. I'll mention quantity number 2 and K15, same tag number. I'll extend over here. It's a K15. So the banquet cooking section has been completed. Now the next is microwave oven. Here it is the same capacity microwave oven. K10 is also here. So K10, we need to copy this and give it to here. and mention the K10 quantity number 2 quantity. There will be the two quantity. One is here and another is the here into the all-day dining kitchen area. Here it is also an electric cooking range. The next one is K17. I'll give over here K17 for this cooking range. This cooking range is quite different than the K16. That's why I have given it as K17 electrical hob or cooking range. Quantity is 1. The capacity 2500 watts single phase. And this frying section doesn't require any electrical supply. So this is what I have completed, the power supply and the required wattage as well as the tag number for all kitchen equipments. So I have completed the chart. I'll give the heading, that is chart for electrical power equipment for commercial kitchen. This is what I have completed. So this is the chart which I have completed. The next one is the legend. Location of switch and sockets for each electrical kitchen equipment. But for that we required the symbols and the electrical accessories and its capacity as well as quantity for the entire kitchen area. So this is the legend, or I will say it's an electrical legend of electrical accessories. So this symbol reflects as LED luminaire, ceiling suspended. These are the luminaires or the lighting available into the all area for the entire kitchen. So this lighting called as LED luminaire in bracket ceiling suspended. It's a ceiling suspended LED luminaire. The capacity of this luminaire is approximately 20 watts and the quantity available the entire area is, to find out the quantity we required the command like filter command. So let us type FI, that is the filter command. Then this filter command we can count the number of LED fixtures ceiling suspended available into the kitchen area. So add the object like this, and the object is the block, the layer name is electrical lighting, block name is LED light, and delete all these other areas like block rotation, normal vector, color, each and everything. The only we required is block, layer name, line type and block name. Even line type is not required. So apply this to the entire drawing. You will get the number of LED lighting at the ceiling suspended, and that is around 36 found. So the LED lighting is 36 numbers. So I will mention over here. The next symbol is LED luminaire, but the wall mounted. And the capacity is also same, that is 20 watts. This LED luminaire requires some special areas like the waiter restroom and so many other areas. Here I have put only in a waiter restroom. This is a wall mounted tube light. In a normal language we can call as a tube light, but in electrical language we can call it as a LED luminaire, that is wall mounted. It is around 20 watts and the quantity is the same. We need to find out like the filter, add the object, take this typical object and delete all the other feed and count that how many LED luminaires of the wall mounted is available. That is only one. That is only one found. So I will mention over here this only one number. The next is the downlight. This is called as a LED downlight. Ceiling suspended. So how many LED downlight is available? We can find out easily by the same command, that is filter command. Enter this filter command. As I told you, add select object like this and delete all other information like this. Only what we require is the object, that is block, layer and block name. Other information not required. So apply this and count that how many downlight is available, and that is around 16. So this is how can we find the each and every symbol and each and every downlight. LED downlight, that is 16 numbers. So I need to mention over here 16 numbers. The next one is, this is the switch, this is the single socket, this is the 3-pin socket, or we can say 3-phase socket, this is the power point, this is the industrial socket, and this is the cable, that is the power cable. All this rest quantity we need to count by drawing the layout. So let us start how to select the switch and socket for each and every equipment available into the commercial kitchen area. So as per this electrical legend, I have mentioned over here the single socket, a single switch. This is the single switch. Capacity need not to be mentioned for the single switch. Quantity, we need to check the quantity from the drawing. This is the single pin socket which required for the commercial kitchen equipment. So the single pin socket, the capacity of single pin socket is the 6 ampere. Then the next is 3-pin socket. The capacity of 3-pin socket is 6 ampere to 16 ampere, or it is also called as 6 ampere to 16 ampere, 6 by 16 ampere. The third one is power supply point. It is also called electrical power supply point. Need not to mention the capacity, as the capacity is vary as per the equipment. The next is industrial socket. The capacity of industrial socket is 32 ampere. This industrial socket are using for capacity having more than 16 ampere for the heavy duty electrical equipment. So we have mentioned over here the single switch required to on off for the electrical equipment. This single pin socket requires for the low weight or the lightweight electrical equipment. The 3-pin socket used for a medium size or the capacity of 3000 watts or the more than or the maximum 4000 watts, and the electrical power supply point requires for the lighting, fans, etc., etc. The industrial socket requires for the heavy duty electrical equipment like refrigerator, then air conditioner and the other heavy duty equipments. So I have mentioned all these equipments, the electrical legend. And the last one is power supply cable. Capacity need not to mention for the power supply cable. So here I have mentioned all the electrical legend as per the requirement, and these all legends are need to install into the each and every area of the kitchen. So let us start from the dishwasher. So this is the dishwash area, and this dishwasher has the 3000 watts capacity. This dishwasher has the 3500 watts capacity. So the switch and socket required for these two instruments will be the same. But we need space where we are going to install or where we are going to put this switch and socket. It is very common place that which can be easily accessed by any person. So let us give the switch and socket at the entry point of any room. So here I will put the switch and socket. So this is the entire switch and socket legend. I will take this single switch and place over here. Before that, let us freeze all the layer so we can easily install the switch and socket at the required area. So here I have just put the socket. Add here we can see 1, 2, the light, 2 light is also there, and 2 electrical equipment is there. So total 4 numbers of electrical equipment is available into this dishwash area. So here I need to put the 4 number socket, the 4 number switch as per the electrical equipment, and one additional switch is also there. So here is entire 6 number switches is there, and the socket required is like this. One socket required for this entire room. So I will take the 3-pin socket from the legend and install to this room. So this is what I have just installed. You can make the scale, you can reduce the scale like this. This is the common 3-pin socket required for this entire room, and this switches is just like I will mention only 2 switches. One is for this socket and another is for 3. I will provide the 3 switches. 2 is for this lighting and 1 socket is for the entire area. And the dishwasher. For the dishwasher, we need to install the socket nearby to the dishwasher like this, so it can be easily accessed. One switch and one socket, 3-pin socket will be there for the dishwasher. The same thing we need to do here also. So I have completed this dishwasher and 2 number dishwasher and the 2 lighting. Now I need to mention the power cable for this electrical equipment like this. For that, just put the power cable on the layer of the power cable, and it will be like this. This socket to this socket, from here to this, and from here to this. So here I have mentioned, here I have just drawn the power cable required for the LED luminaire as well as the dishwasher. So 2 number dishwasher, I have mentioned the switch and socket for this dishwasher, and for this dishwasher I have mentioned switch and socket. Also I have just shown the 2 switches for each LED lighting and a single switch for this socket. So we can use this 3-pin socket for a multiple purpose. So this is just I have completed this dishwash area. The same thing we can follow into the room service. In this room service, I can see that coffee maker, tea maker, juicer mixer as well as the LED lighting, these are the common electrical equipment available into this room service. So we need to find out, and the induction stove is also there. So here are almost 4 plus 1, that is total 5 numbers of electrical equipments are available into room service. So at the entry point, let us copy this, and same thing I will show here, that is 3 switches, 2 switch for independent LED lighting. So here I will draw like this. So this is I have just shown the power cable for this LED lighting. Then this juicer mixer, coffee maker and tea maker. Let us give here the switch and socket for this tea maker, or we can use the common for this coffee maker and tea maker. We can use alternate for coffee maker and the tea maker. This switch socket, this is the switch and this is a 3-pin socket we can use for this coffee maker as well as the tea maker. Keep the separate 3-pin socket and switch for this mixer or juicer, and the location of this switch and socket must be near the electrical equipment like this. Make sure that switch and socket must be easily accessible for the electrical equipment, so we can run that electrical equipment very easily. So we need the power cable like this, from here to here, and same from here to here, also from here to this juicer and mixer. So I have just drawn the power cable for the juicer mixer, coffee maker and the tea maker, and I have given the switch and socket for this entire room service. The same thing we will follow with cold kitchen. In this cold kitchen, we have just left this induction stove, so we can put this cable connection, power cable with this. So the entire induction stove can be run on this switch and socket. Now let us come to the cold kitchen. In this cold kitchen, there are 3 LED lighting is there, as well as induction stove which is run on an electrical supply, as well as the refrigerator is also there. For the refrigerator, we can give the 3-pin socket, as well as induction stove we will give 3-pin socket, and for this LED lighting we will give the separate 3-pin socket at the entry point. So here let us copy this and count that how many LED is there, LED lighting is there. So 1, 2 and 3. So 3 plus 1 switches will be there. The orientation of the switches must be like this. It must be like this. So this is, I have just shown the 3-pin socket and the 4 number switches like this. For this induction stove, 1 switch and 1 3-pin socket will be there. For this refrigerator, we need to show the industrial socket, because the commercial refrigerator capacity must be or may be higher than 16 ampere current. So I have given over here the industrial socket for this refrigerator. Then the power cable from this socket to this, then from this refrigerator to like this LED lighting from here like this. We can draw like this one, this switch for this, and this is for this, and this is the spare switch for this 3-pin socket. So we have just completed this dishwash area, room service and cold kitchen. So this is just I have completed this dishwash area. The same thing we can follow into the room service. In this room service, I can see that coffee maker, tea maker, juicer mixer, as well as the LED lighting, these are the common electrical equipment available into this room service. So we need to find out, an induction stove is also there. So here are almost 4 plus 1, that is total 5 numbers of electrical equipments are available into room service. So at the entry point, let us copy this, and same thing I will show here, that is 3 switches, 2 switch for independent LED lighting. So here I will draw like this. So this is, I have just shown the power cable for this LED lighting. Then this juicer mixer, coffee maker and tea maker. Let us give here the switch and socket for this tea maker, or we can use the common for this coffee maker and tea maker. We can use alternate for coffee maker and a tea maker. This switch socket, this is the switch and this is a 3-pin socket we can use for this coffee maker as well as the tea maker. Keep the separate 3-pin socket and switch for this mixer or juicer, and the location of this switch and socket must be near the electrical equipment like this. Make sure that switch and socket must be easily accessible for the electrical equipment, so we can run that electrical equipment very easily. So we need the power cable like this from here to here, and same from here to here, also from here to this juicer and mixer. So I have just drawn the power cable for the juicer, mixer, coffee maker and the tea maker, and I have given the switch and socket for this entire room service. The same thing we will follow with cold kitchen. In this cold kitchen, we have just left this induction stove, so we can put this cable connection, power cable with this. So the entire induction stove can be run on this switch and socket. Now let us come to the cold kitchen. In this cold kitchen, there are 3 LED lighting is there, as well as induction stove which is run on an electrical supply, as well as the refrigerator is also there. For the refrigerator, we can give the 3-pin socket, as well as induction stove we will give 3-pin socket, and for this LED lighting we will give the separate 3-pin socket at the entry point. So here let us copy this and count that how many LED is there, LED lighting is there. So 1, 2 and 3. So 3 plus 1 switches will be there. The orientation of the switches must be like this. It must be like this. So this is, I have just shown the 3-pin socket and the 4 number switches like this. For this induction stove, 1 switch and 1 3-pin socket will be there. For this refrigerator, we need to show the industrial socket, because the commercial refrigerator capacity must be or may be higher than 16 ampere current. So I have given over here the industrial socket for this refrigerator. Then the power cable from this socket to this, then from this refrigerator to like this LED lighting from here like this, We can draw like this one, this switch for this, and this is for this, and this is the spare switch for this 3-pin socket. So we have just completed this dishwash area, room service, and cold kitchen. Now come to the electrical equipment, that is kitchen equipment. The first one is microwave oven. For this microwave oven, give the switch and socket like this. For the special microwave oven, then electrical hob required, a separate switch and socket, tandoor required, electrical tandoor required, separate switch and socket like this. Idli maker and the hot plate dosa maker has the separate switch and socket like this. Here I can show the switch and socket. This OTG also required something like this. So this is I have just shown. This microwave oven can connect with this 3-pin socket. This electrical hob will be connect with this switch and socket, and this electrical tandoor will also connect with this switch and socket. Idli maker and electrical hot plate for dosa can be connected commonly like this. It can be used alternate. If we are using a idli maker, we cannot use the dosa maker, or when we are using the dosa, we cannot use the idli maker. So this is the way I have installed the switch and socket for this common switch and socket for idli maker and the dosa. The next one is gas hob. Gas hob doesn't require any electrical power supply because the supply is taken from the gas cylinder. OTG. I have given this OTG, and this is the connection I have given with the switch and socket. Now the rest of the thing is here. There is the grill or toaster. Copy this switch and socket and give it at here, maybe at this area. Always keep the switch and socket away from the water area. So this is the water area, this is the wash basin, so that's why I have keep the switch and socket here. The connection will be like this. Now come to the grocery store. Into the grocery store, we need to show the switch and socket like this. Two switches for the LED lighting, and one is the common switch for 3-pin socket. So here I will draw the cable like this, and this switch is the spare for this 3-pin socket. So this is the grocery store. So we have just completed this main kitchen area. Now for this common lighting, this is the common downlight. For this common downlight, we need to give the common power supply cable. For that, we require the electrical power supply point like this. Between this For this 2 downlighter, the supply point is like this. For the downlight, from here, this is the common supply point, and this supply point will be connected afterward with the main DB or the lighting DB. Again, here is also required the power supply point like this. The same power supply point is also between these two, like this. So I'm showing this power supply cable connection from the main power supply point like this. This power supply point is coming from the conduit. The main conduit is running from the ceiling, and this is also called as the junction point of the conduit. So from here we can take the power supply, or we can draw the cable from this point. That's why we are calling this as a power supply point. This is also required, a power supply point like this between these two, so we can easily give the power supply like this, here to here, like this. This LED can be connected from here like this. So this is, we have connected the entire passage area LED lighting with the power point. We can take the power from the conduit and from the power supply point, and we can on that LED lighting. So as we have completed this side kitchen area, and let us start with this banquet cooking section. In this banquet cooking section, these are some electric equipment, that is electric hob, electric tandoor is there, and refrigerator is there. Deep fryer doesn't require any electricity, as well as the cold tandoor doesn't require any electricity. So in this area, in this banquet cooking section, these are some electrical equipment, and we need to give the power supply for this equipment. So I'll copy this I'll copy this 3 pin with sockets and give it to the proper location like this. This refrigerator requires one switch and one socket, 3 pin socket. This electric hob required one switch and one socket. This electric tandoor required one switch and socket like this. Now I have copied over here refrigerator, electric hob as well as electric tandoor. One more thing, that in this banquet cooking section, these are the LED lighting. For this LED lighting, we require switch and socket. So at the entry point, we need to give switch and socket like this. One switch and socket for this electric tandoor, another switch and socket, one socket will be there, and two switches will be there. That is for, one is for lighting like this. This is the cable like this, and this is another cable for the same switch. This switch is for 3-pin. So I have just mentioned over here, or we can connect it like this from here and from here to here. It means I have connected these three lighting with the single switch, and another single switch is for electric tandoor, one this switch for this 3-pin socket. So I have completed this banquet cooking section area. Same walk-in cold storage is here. Into this walk-in cold storage we require a 3-pin as well as the socket and switch. It will be like this. Keep this. There will be two switch and one socket like this. And this socket is required for this entire walk-in cold storage. Instead of 3-pin socket, we can use the industrial socket for this cold storage area. Here also we required one switch and socket spare for the spare purpose. So we have completed this banquet section area. Now come to the all-day dining kitchen. The all-day dining kitchen has the multiple equipment, but the main electric equipment is the microwave oven, then this electric cooking range, as well as this hob. This hob is electric hob. So we need to highlight this, lay an ISO, lay unlock. So this is what I have just unlocked, and convert this into the layer. To convert this into the layer, we require to select this and highlight this by cyan color, as this is the electric hob. So what we required is, again we require to lock this layer, lay LCK, that is lock the layer, lock the text, and now this is the 17, maximum 17 is here. Let us unlock the layer and add one more electric hob like this. It's an electric hob and the maximum capacity is 2500 watts for the single phase. Now make layer unlock and convert this layer into electric kitchen equipment like this. And then lock the layer. Now here I can see, so this is a microwave oven K10, then K10 is what? Here it is, microwave oven. K11, 12 are here up to K17. So last is the K17. I will give over here K18. That is electric hob. Again I need to highlight this one. So I need to unlock this one and need to highlight this bain marie. Bain marie is the electric equipment using in the kitchen to prepare the hot food. So convert this into the kitchen layer, electric kitchen equipment, and give it to the bi-layer. So this bain marie become the electric equipment, and I want to give the K18, want to give the tag number, that is K19. So here the K19 is the bain marie. One number. The capacity for the bain marie required 3000 watts, a single phase. These are the kitchen equipments into all the dining area. So at the entry point, here is the entry. So I will give the switch and socket like this. Make the group like this main kitchen of LED. These are the 8 numbers LED, 1, 2, 3, 4, 5, 6, 7, 8. So I'll make the group and convert this into the switches. So here it is, 1, like this. Again I will prepare like this. Again need to prepare like this. So one loop has been completed for one button. And another one is like this. Change the color of this cable. So we have just connected this and we need to change the color of this. Match the color. This side like this. So I have just completed. The LED lighting wiring of in this stage, and the next is micro oven. So for this microwave oven we required one switch and one socket over here. Then for this electric hob, one switch and one socket required. For this electric cooking range, one switch and one socket required. So here I can connect like this directly into the socket. Again this one will come into the socket From the microwave oven, this will be directly come to the socket. So these are the wiring connection, power cable connection with the socket as well as the electric equipment. So we have just completed this power cable connection with the switch and socket of electrical equipment. So student, we have just completed this drawing, that is electrical power supply for commercial kitchen, step by step, and these are the steps for electrical power supply layout for commercial kitchen. The first step we have completed, that is introduction of kitchen equipment with the wattage and tag numbers. We have given the tag numbers. Then location of switches and socket for each electric kitchen equipment that we have done. The third one is wiring connection or the cable connection from the main DB to switch and socket to electrical kitchen equipment. We have done that. Then fourth number is the power supply point legend, that we have given the power supply point legend. Here is the electrical legend, the power supply point. There is single switch, single pin socket, 3-pin socket, electrical power supply point. These are the number of power supply points that we have given. Fifth number is list of kitchen electric equipment. The list of kitchen electric equipment we have given with the tag number, kitchen equipment name, quantity, power requirement and the phase, whether it is single phase or the 3-phase. Sixth number is power distribution schematic diagram. Now we are going to prepare the power distribution schematic diagram. In this diagram, we will learn how to design the power schematic. So this is the layout for the power supply schematic for the commercial kitchen. Let's start the schematic diagram. In this diagram, I'll design the main DB. This is kitchen electric DB. So I'll give the name. This is main DB for kitchen electrical equipment. Main DB, that is main distribution board for kitchen electrical equipment. So here is the main DB. There are actually two types of DB required for the kitchen. One is for main DB for kitchen electrical equipment and another DB for lighting, that is lighting distribution board is also there. So in this diagram, I'll distribute the DB into two parts. One is for kitchen and another is for LED lighting. So another DB is for electrical lighting. This is the schematic diagram that I am preparing right now. DB for LED lighting, and the power is coming from main circuit breaker, 3-phase, 415 volts. So into this main DB, firstly I will draw the main DB and then the DB for LED lighting. So in main DB for kitchen electrical equipment, we required NCB, NCCB, RCB and ELCB. This is MCCB symbol. So I'll mention over here. This is main MCCB. Here it is MCB, that is miniature circuit breaker. This MCCB called molded circuit breaker then RCCB, residual circuit breaker, and this is ELCB, earthing leakage circuit breaker. So these are the main circuit breakers required into the main DB. So this is the bus bar. This is called bus bar. Now from this bus bar or from this main electrical DB, we required the multiple connections for the sub DB, that is sub distribution board is also there into each and every kitchen. So right now we have, these are the four main kitchens, that is all day dining kitchen, banquet cooking kitchen, and the main kitchen. These are the three main kitchen is there, and these are the small kitchens like room service, then cold kitchen. These are the small kitchen. So we will make a four part for this entire kitchen. One is from this bus bar I will draw. I will start from here, that is all day dining kitchen. This is all day dining kitchen. Then next one is banquet kitchen, and the next is main kitchen, and this is rest of the kitchen area. Rest of the kitchen area. So these are the four main branches that I have done, and from this all day dining kitchen, which are the electrical equipment available into the kitchen. So on each kitchen we required 1 dB, that is called sub dB or the sub distribution board. So keep nearby a sub distribution board which can be easily accessed. So I'll put over here, this is called sub dB. This is the sub dB. So in this sub dB, all the electrical equipment power supply will be connected. So here in the all day dining, these are the equipments, that is K10, K17, K18 and K19. So from here we will draw like this. Let us take this distribution board symbol, that is sub dB. From here the branches for the kitchen electrical equipment will be like this. Something. This is the socket symbol. This is the typical socket symbol, like this. Make it bigger, something like this. So this is the socket, and this is the switch symbol. So it will be something like this. Into this, what we required is so from here K10, K17, 18 and 19. So first is K10. K10, or here it is K17, K18 and K19. Let me make this text higher. The text height, change the text height like this, and so it can be easily visual. So all text height must be 300. Keep the constant height. So all the dining kitchen that we have completed. Same banquet kitchen. Now into the banquet kitchen, there are how many equipments is there? One is K16, K15. Only two equipment is there, K16 and K15. So let us start with these two equipment. Here it is at the same. So K16, K15, I'll mention over here K15 and K16. Next is main kitchen. Into the main kitchen there are multiple kitchen equipment. Electrical kitchen equipment is there. K10, K11, K12, K15, 14, K13. So from K10 to K15 we need to give the space for that, so it will be like this. Make this height also 300 instead of 200, so it can be easily read. This is the banquet kitchen. To the main kitchen, copy this dB to here also and name it, that is sub dB. This is the sub dB. Keep the arrow size of 250, matching that text. It can be something like this. These are the dBs. So into the main dB, starting from K10 to K15, keep this RCC. Here it is, the main kitchen. K10, K11, K12, 13, 14 and 15. So main kitchen has been done. Main kitchen, then sub distribution board. This is the switch, this is the socket, and this is the switch symbol, and these are the equipment connection. So power supplying to this K10 to K19. Now this is the rest of the kitchen area. So into the rest of the kitchen area, these are the main equipments, that is from K1 to K9. So from K1 to K9, make mirror like this. and keep something the rest of the kitchen area. This is the sub dB, and here it is. We can give 01, 02, but before that mirror this and keep going like this. 1500. So 1, 2, 3, 4, 5, 6, 7, 8, and last one is 9. So 5, 6, 7, 7, 8, and the last one is 9. So from 1 to 9, these are the connection from the sub DB. So this is what I have completed, this main DB for kitchen electrical equipment schematic diagram. So copy this text over here and make distribution board for lighting, or it is also called lighting DB. In this lighting DB, we need to give same MCB. Instead of MCCB, MCB is enough, so make it MCB. Miniature circuit breaker. RCCB, PLCB. Here we can write for LED lighting, and this is for 3-pin socket. So this is what we have completed. From the main circuit breaker, the power supply is coming from the main circuit breaker to the main DB for kitchen electrical equipment, and the distribution board or the DB for lighting or lighting DB for LED lighting. So from the main DB, in the DB distribution board contains the MCCB, that is molded circuit breaker, then MCB, miniature circuit breaker, RCCB, that is, or the RCB, that is residual circuit breaker, and the ELCB, that is earth leakage circuit breaker is there. From all the circuit breaker, these are the main 3 point is supplying to the main 4 kitchen areas like this. The kitchen area, that is all day dining kitchen, banquet kitchen, main kitchen, rest of the kitchen area is there. So this is what we have completed, the electrical power supply schematic for commercial kitchen. So prepare some incompleted, that is, add this symbol called distribution board DB in bracket distribution board. Need not to mention the capacity as the capacity varies. It doesn't require the quantity also, because quantity can be matched with the drawing. We can calculate the quantity from the drawing. So this is, we have completed the electrical power supply layout for the commercial kitchen.